I just forgot. Okay, now you're good. Sorry about that. All right, so recapping part B, we got a late start on the recording. Sorry if you're tuning in. That's my fault. So for part B, we said we're going to integrate the velocity from 0 to 5 via t dt. Gave me s of 5 minus s of 0, which was 10. We tossed the 10 over, and then whenever we plugged it into a calculator, we got 10 minus 19.207. Final answer, negative 9.207 is s of 5. Okay. So does anybody need help with the calculator? To get that integral, you're doing math 9. Make sure you guys know that there's a difference between a subtraction and a negative on the calculator. If you're trying to do a negative symbol, you're at the very bottom. If you're at the trying to do a subtraction symbol, that's in the far right column. There's two different keys. So if you're getting any trouble, that's probably where it came from. Okay, that all said, does anybody have any questions on part B?
Yeah, what's like the 5 times 5? Would you get that from?
Did you 5 times 5? 20.
Or
What?
whatever. The 5 times whatever in the parentheses, like.
Oh, this is S.
Oh, okay.
S. That's the same thing as x of 5. Just for whatever reason, they're using S in this problem. They have two different letters for position, x of t and s of t. Whatever they pick is whatever they pick. So that just stands for s of 5 is our position at 5. Okay.
Okay.
Any other questions, guys, on part B?
Mr. Baker?
Yep.
How come there wasn't the absolute value symbols around the equation this time?
That only stands for total distance traveled. The absolute value of velocity integrated is total distance traveled. This is just plain old velocity, doesn't talk about total distance traveled. So the only time you see those absolute value symbols with that and you integrate it is with if it's total distance traveled.
Oh, okay, thank you.
Mm-hmm. All right, guys, on to C. We want to find all the times where the particle changes directions on 0 to 5. So you should know what's going on there. That's going to be graph the velocity. Check where it changes signs. So now note that this was plural. It said find all the times where it changes directions. That usually means more than one. They don't usually have typos. So if it's plural, they're looking for more than one. Find all the times. So if we were to pull up our calculator, hold on, let me find mine. Okay, if we were to pull up a calculator, we would want to graph the velocity. So, hang on, give me 1 second here. Let me delete this. Okay, when we want our window to be, is it 2 to 4? I lost track of the problem. Is that what they said? 0 to 5? 0 to 5, okay. All right, so here's our velocity. And if it's below, the thing's moving down and to the left. If it's above, the thing's moving up and to the right. The 0 of the function is where it changes directions. So you can see here, this thing has two zeros. One of them's here, one of them's here. To find a 0, we hit second, we hit trace, we go to 0. We hit enter, and this is your left bound, right bound guess. So here's a little trick, guys. And if you don't like scrolling for eternity, you can just type in something to the left. So like, in other words, I'm trying to find this guy here. I know that 0 is to the left of it. I'll hit 0. Right bound, I can clearly see that 1 is to the right of it. I'll hit enter. Saves you a little bit of scrolling time. Just make sure you're putting stuff in that is truly to the left and to the right. And then for the guess, you can just slide it over and you've got your answer. So you can just type in a number as well. So the first one I'm coming up with is 0.536. And then we're going to do this again. Start all over from scratch. Second trace calc 0. All right, left bound. Let's pick something left here. 1, 2, 3. So 3 would be to the left. 4 would be to the right. And then I'm just going to slide the cursor up for anything in between. And that's going to give me my other one. And I've got 3.318 round to the third one. So your answer to this would be, the particle changes directions at t equals such and such and such and such, the two answers I just read you. And here's the only thing, I just said that wrong. You want to list these separately. They change differently, right? So the first one, whatever that answer was, 0.5, whatever, it's changing directions there because velocity changes from negative to positive. And it also changes directions at 3.318 for a different reason, because velocity changes from positive to negative. So kind of like we did with points of inflection, how we listed them separately based on the change. Same deal with these turnarounds. List them if they change differently, explain them in that way. Any questions on C? Okay, heading on to D. Easy. You see this one, you should be happy. We want V of 4, A of 4, compare the symbols. So we want V of 4, we want A of 4. To look up V of 4, all you're doing is, go back. Hang on. So we've got our velocity function here. So we would hit trace 4, enter, velocity is negative. To find your acceleration, we're going to do math 8 dd what? ddx. I'm going to plug in 4 to my derivative, and into that parenthesis set, you would need to type out the velocity formula. And when you do that, this problem, is it also negative if my memory serves me correct? So then you would write your answer out. At t equals 4, the particle is slowing down because velocity at 4 and acceleration at 4 are both negative, or both less. Just copy that part right there. Okay. So that takes you to part D. Any questions on BCD?
Yeah, from part D, could you when you graph it, could you like look at what it's at around 4 to determine?
Yes. Now, now hold on. We gotta be careful. Yes to what you just said, but make sure you're real sure about it. So in other words, let me trace the 4. All right, at 4. Now here's the first problem. I can't see it on the graph because this only goes to 10 to negative 10. So I want to make sure I can see this. So I'm going to go down to negative 15. Okay. I'm going to go down to negative 15, and then we'll see what's going on here. Because think about it. If I'm approximating acceleration and I'm staring at velocity, isn't that just a tangent line? One derivative further? Does that make sense? In other words, even though it's velocity, the derivative of velocity is acceleration. So if I head to 4, there's that point. What would the slope of the tangent line be here? It'd be negative, right? So then you could approximate that A of 4 is less than 0. That said, though, you got to see it to make that approximation, because if your graph did one of these, say it was going down and you got cut off, and then you thought, oh yeah, it keeps going. But all of a sudden it actually did that, and it curved up and you couldn't see it because you were only looking at that much of it. There's a chance they could do something like that to you, and you would need to just make sure you can see it. That's all. Okay.
Oh, okay. Thank you.
Sure.
Mr. Baker, quick
Yes.
question. Just to recap, so in what situations is the particle speeding up, and in what situations is the particle slowing down? Because
Pretend you're
is it like-
multiplying the results. So I'm going to get two symbols and I'm going to multiply them together, even though you're really not. You're just going to pretend you are. So if I get a plus plus or a minus minus, plus plus gives me a positive, minus minus gives me a positive. If I multiply one of each, that gives me a negative that would slow down. Does that make sense?
So then in part D, is it speeding up?
What do we have? Two. Yeah, did I not say that?
Okay, you said slowing down.
Ah.
That's why I was really confused.
Cool. So then you know what you're talking about even better than I do. Yeah,
Okay.
it's speeding up. I probably just said it way too fast. Yeah, if you get the same symbols, just think of it as I'm multiplying the results. So it's going to be, if I multiply a positive and a positive, or a negative and a negative, we're heading up. One of each is going down. Sorry if I said that wrong. If we're at the part of the year, though, where you guys are correcting me, that means you've learned what you're doing. So Sounds good. All right, part A, let me teach you what you need for part A, and then we'll be out of here. So part A, let me share the screen. All right, part A. What's it ask for? It asks for speed. We learned about that earlier in the year. Does anybody remember what that is? There was a definition I gave you. I don't know if you remember it or not. I mentioned it vaguely a couple times, but we didn't really do much with it. Speed was I gave you a reference for it. Does anybody remember?
It was like distance over time, right?
That's not entirely wrong either. Yeah, but we're going to call speed. It has a special definition. It's the absolute value of velocity. Speed is the absolute value of v at t. Now, this is not an integral. If you integrate speed, that's integrating the absolute value of v at t. That's what's giving you total distance traveled. Just regular old integral of velocity gives me speed, because like your velocities can be going in different directions, but if I guarantee them to be positive, that's when you're just talking about a speed. And truth be told, I'm not a physics major, so my explanations aren't going to be like to the T of a physics book with this. It's just the general idea is if you keep this positive, that's what results in a speed. So that all being said, we want to know where on the graph is the speed to. So we got to think about what that means. All we have to work with is a velocity graph. So here's my graph. Think about what this means. This axis means time. This one is your velocity. And when we graph this, let's think about what we had for a graph. It looked something like that, right? So if I want to know where this velocity is to, so we got to think about what we're doing here. You can't plug in 2. That would tell me the velocity at t equals 2. So in other words, I'm just going to make these up here. Let's say there's 1 and here's 2. And so at 2, you're up there, which that's nice. That's the velocity at t equals 2. I want to know when is the velocity 2. In other words, if you scroll over here, I want to know at what time it's at 2. It's 1 point something, but they're not going to give you credit on the AP board for 1 point something. How could I map this out and figure it out? I can't trace the 2. Trace the 2 gives you the X value. That would shoot me up there. We'll just label that as wrong answer. So if I do trace 2, that's going to shoot me up to the wrong answer. I want to know when's the velocity to, at what X value. Ideas. Somebody give me a plan.
You could find the slope, and then
How am I finding the slope?
you could take the velocity in time, and then you could set the velocity on top of the time, and then that'll be the slope of it. If it gives you points, though.
Yeah, we don't have any points though.
Is it the mean value thing?
Not quite. So here's all we're trying to do. We're trying to just pinpoint what this is. And currently all I have is one graph. So how about this for an idea? What would happen if I inserted this line, and we'll give it a name in a second, but for right now, it's a horizontal line. And here is this horizontal line at 2. So that equation would be, y equals 2. And we're going to call this a tracer line. So it has no bearing on the problem, except it gives me a way to find exactly what I want. So I know I want 2. So now if I create this tracer line, check it out. What can I do with the tracer line and the blue velocity graph that'll pinpoint exactly what I want? Finding the what? Finding the what? No, I don't want to integrate it. Way back to algebra 2, easier than that. I want to find the what of those two lines, the two graphs.
Intersect.
I want to find the intersection. Yeah, it's exactly what it is. So the tracer line is just this little fake line we put in that lets me, though, find the intersection of the red line and the blue line And when you find the intersection of two lines, it gives you an X and a Y. So the X value of that intersection is going to be the answer you're looking for. Now, I'm just scribbling this out. I don't know what the real dimensions are, but does that idea make sense? We'll go try it on the calculator in a second. Now, there's one more piece to this puzzle. This is the absolute value. Speed's the absolute value. Means I got to keep the answer positive. So if it's right here, yeah, that's definitely going to be a final answer at 2. But what if we did this? What if we did -2? Speed's the absolute value of -2. So even though this is at -2, what's the absolute value of -2? 2. So when you do where is the speed problem, it's going to be both positive and negative tracer lines needed. And we only want to do one of them at a time. Okay. All right. So let's go check out how that looks on a calculator. So we're going to, give me one second. We're going to go screen. All right. Part A, find all the values of t where the speed is 2. Got it. We're going to go to the calculator. We're going to graph velocity. We got it. We're going to graph the tracer, y equals 2. We got it. And now there was one more piece to that puzzle. It gave me an interval and it said, we only want to look at this problem from 2 to 4. You got to make sure you change your window or you're going to get stuff wrong. So now we're looking at the velocity from 2 to 4. And we want to know where these things intersect. If you want to know where something intersects, you're just going to go to the same exact menu you would for the 0. So hit second trace calc, pull up the menu. Which option do you think we need?
5.
5. We're looking for the intersection of the tracer with the velocity. So I hit enter. Calculator will run you through the directions necessary. It's first curve, enter. Second curve, enter. Take a guess, enter. Bang, we got an answer. 3.128, and you're good. So at t equals 3.128, the speed of the particle would be 2. Now you need to go do the same thing for -2. So I'm going to stay quiet for a minute. You guys go to graph, take out 2, replace your tracer with -2, check it out and see what you get. Ready, go. All right, what do we get? Anybody?
I got 3.473.
So we're going to graph it. We're going to put a tracer at -2. We're going to do a second trace number 5, intersection, enter, enter, line it up, enter. And I get the same exact thing that you just said. So you're good. Questions, guys? All right, so let's take a peek at this problem one more time now. Start to finish, no math, just checking out the ideas. All right, ideas here. find all values of t where the speed is 2. You're going to hear me call that the tracer problem. Do the tracer. You should know what that means from now on. Second one, that's FTC. If you can just look at each piece of a particle motion free response and say, you know the plan, you're going to be fine. Second one's FTC. You should know what that means. Third one, where's the particle change directions? That's going to be our graph the velocity, find where it changes directions, locate the 0 or zeros. Last one, speed increasing or decreasing. That's where you find V of whatever and A of whatever, compare the symbols, go from there. Does anybody have any questions on the plan or on the calculator involving A, B, C, D? Okay, guys, I have work for you. You will be busy this weekend. So on Canvas is a boatload of calculus that I need you guys to practice and try. You've got Thursday, Friday, Saturday, Sunday, all the days, lots of time. So I don't see you till Monday at 3:30. So you need to grab that assignment, work your way through it. You can use a calculator on this particular one. That said, I'm also comfortable with you not wasting your time. If you are looking at problems in this packet and you truly know, like, yes, I know how to do this and I'm wasting my time, skip it. I don't care. But you have to be very honest. And like 70, 80% of that packet should be questions where you're saying, yes, I should probably practice this. But if it's something crazy easy, if you know MVT inside and out, whatever, skip it, that's fine. But make sure you're working through 70, 80% of that packet. And then Monday we will be going over that. So does anybody have any questions? Okay, Bennett, you can turn it off. That's it. Give me 1 second, guys. I'm going to take